Okay, so we know about nested loops, right? What are nested loops? Loop inside a loop. Okay, so you can place. So the number of loops which you can place inside a loop is endless. You can place as many loops as you want. Okay, and it's important to know that how many times a loop will run. Okay, so for example, if I have a loop, just directly go to the slide here. Okay, so you see here we have two loops here. Okay, so the I loop, which is the outer one, it will run how many times? 4. The inner loop, which is the J loop, it will run how many times? 5? 20. Okay, because it will run 5 times, and then it will run again with the second loop of I, then again with the third loop of I. So total 20 times. Okay, so this is the important thing to know, and how many times the loop is going to run. Okay, so let us use loops to transpose the matrix. Okay, just give me 1 second. Now you see another command, which is CLC. Clear will clear the variables from the workspace. So if there was already a matrix A, it will clear it. If there was a matrix transpose of A, it will be cleared from the memory, from the file. CLC will clear your screen. Okay, so you will just see the programming which you are doing right now. Okay, so if you use any other commands before, they will all be cleared. Okay, so like I said, these are good programming habits. Using clear at the start, using CLC, using semicolon, all of them are good programming habits. So when you run the program, your screen will look neat and clean. You will not get confused. Okay, so keep them in mind. Okay, now same problem, and we want to do the transpose, but we have to check if the matrix is a square matrix or not. If the matrix is a square matrix or not. Okay, if it is not a square matrix, the program should not run. Okay, it should display a message and the program should end. Okay, so we have the same program. Okay, the only change will be where. Where should I change, and what should I put? Tell me. I want to run this program if the matrix is a square matrix. Square matrix means what? 4 by 4 is a square matrix, and 2 by 2 is not a square matrix. N equal M, rows equals columns, right? Okay, so now tell me, what should I add here to tell the program only run if you have M equal N? What should I put here? If condition, right? Okay, where? After for J. Ready? For you already started the loop, right? If it's not a square matrix, then should the loop run? No. So where should the condition be? Before the loops. Okay, this is what I was telling you earlier for efficient programming. When you are running the loops, make sure it runs for the minimum number of times. And in case of not having a square matrix, we don't want to run it at all. Okay. Okay, so the same things which I mentioned earlier. Okay, and just you can see the difference here. Instead of writing I not equal to j, they are saying if I is greater than j. Okay, because j is inside I, right? So j can be less than I or equal to I. Okay, it's a square matrix, right? So it cannot be more than I, right? J cannot be more than I. Inside the loop, it can be equal to I. So if it is equal, then we have the diagonal elements. We don't want to run it. For diagonal elements, we don't want change, right? So this is the condition, the if condition inside the j loop. Okay, so it is checking for the diagonal elements. Instead of writing a not equal to j, they write I greater than j. Clear? Okay, so you want to write a script which finds a percentage of 0 values in the variable a. Okay, so out of all the elements, how many are zeros? Okay, how many are zeros? 6 out of that's 24. 16, huh? So what percentage? Tell me the percentage now. 6 out of 16, how much percentage? How much is it? So another important practice for writing a program is you can take a simple case and check your program, calculate the answer manually, and for the first time when you run the program, run it for that simple case. So you already have the answer in front of you, and then you can check if my program is working fine or not. Then you can use the same program when you know it is working fine. You can use the same program for more complex cases. Okay, so here A is 4 by 4, right? So once you check it for 4 by 4, so you already did it, right? 6 out of 16, how much? What is the percentage? 6 out of 16? .375, right? So my program should give me an answer 0.375 or 37.5%, right? So I already know the answer. Now I can check with my program. Okay, so whenever you have to develop a program, like not now obviously, here in the during the course you will getting simpler cases, right? But even for those cases, it's a good practice. Develop the program, see the answer of the program, and check it with the manual answers. That's how you know the program is working fine. Okay, here if the program is working fine, you will get the grade, right? And in real life, you can use the same program to do a much more complicated case. So instead of doing it for a matrix of 4 by 4, you can do it for a matrix of 400 by 400. Okay, so another good programming practice, take a simple case while you are developing the program, develop the program and check it with your manual calculation to see that the program is working fine. Okay. Okay, so the first one, same as what I wrote earlier, and the second one, you can see a small change here. Okay, I forgot to put 100. Should be multiplied by 100. But you can see a small change here. Mean of mean equals to 0. Okay. I have tried it without this mean as well. The outer mean, it works. It works for scalar and matrix and everything. Okay, so this one is enough, and this one is not an error. If you put it like this, program still runs. Okay, mean of mean a equals to 0, it still runs, there is no error. If you do it like this or this, it's fine. Okay, why there are two means, I don't know. That's why I'm teaching it in summer. Okay. And you can do the same thing using two loops and an if statement. Okay, so now we know, right, how to use the two loops and the if statement. Okay, what should I do? So we will not use mean and we will not use the sum function. We will use the loops and use the if statement. Okay, can somebody do? Okay, so they are using the size command, you can see here, and the 0 is initiated, the counting is initiated, then we are checking if each element is equal to 0, then count it. If not, don't count it. All the loops are run. Then outside the loop, we are calculating the percentage within the display command, and it can happen. Okay, but inside the display brackets, if you are calculating something or displaying a number, you don't need the quotation marks. Quotation marks are only used if you want to display a text. So you can see here, I'm using quotation marks here on the board, and I'm not using quotation marks here. But this is the variable, this is text. Okay, similarly you can use one for loop and if statement as well. So if a statement will remain the same, right? If a statement remains same. Now how do I make it one loop? How will I make it one loop? So one loop should run how many times? 16, right? So you can do 1 colon 16. Okay, or if you want to put it according to the size, then how do I get the total size of A? The num1 command, right? Okay, so you can run it from 1 to num1 of A, so it will run all the elements. Clear? And then inside the loop I am checking what? Now what was I checking? If A ij, right? So I was running two loops, so A ij. If I am running one loop, then if A what? I, right? And I told you in which order does it go. So I1 means first row first column, right? I2 means what? Second row first column. Okay, so it goes vertically. Another command, instead of num1 they are using the length command, len, same thing. Okay, so len equals to, it's not a command, len equals to the size of A. Okay, clear? Any questions? So you can see same program. In how many ways we did it? All of them work. Same answer. Okay, which is the best one? First one. What was the first one? Sum. What about this poor guy? The mean, right? They are not even asking you to divide by anything. Okay, but obviously for this you should know what is mean, right? Okay, program can be much simpler if you know the right function. If you don't, you can still work the program. Okay, okay, write the script which finds the value of e of x. Okay, now you can see here whatever programs we are doing, they are actually built-in functions in MATLAB. The program which you did with the loop and the if statement, that is the mean function, right? That is the mean function. Okay, so when you say mean, somebody in MATLAB has this in the background running. Somebody developed this whole thing with the loops and if, and then he named it with the function mean. Okay, similarly this program, this is for calculating what? E of x, right? E of x is the exponential. Exponential is already there, is a built-in function in MATLAB. Okay, but what happens in the background when you take the exponential command, when you run the exponential function or command, what program is running in the background? Okay, so it's not rocket science. Okay, Developing these functions for sine and exponential and log and so on is not rocket science. Anybody can do it. Clear? Any questions? In both cases, your answer should be 12.1825. Clear? Any questions? Okay, now pick one of them and run it. Pick any one of them and run it. Okay, so I hope it works, and let us move on. So one thing which you can see here, the loop which I did on the board, it starts from 1, right? If you look at the program, it starts from 0. So in this case, it didn't initiate then. Even the first term is calculated by the program. The first term is what? 1, right? Okay. So you can see inside the where is it? Sum, yeah. So in the first case, okay, it will take x to the power 0, right? Okay. And anything to the power 0 is how much? 1. So when it will run the first time, because of this it will become 1. Because x to the power 0, it will become 1. And so on. Okay. Another thing which you can see in this case is they are calculating the factorial through a loop. So they are not using the factorial function, they are calculating the factorial using a loop. So an additional loop inside the function for calculating the factorial. You know factorial is multiply, right? So factorial initiated with 1 and then multiplied and so on. Okay. So MATLAB takes everything as a vector. Even if you put one number, so when you say a equals to 3, MATLAB will store it as a vector of 1 by 1. Okay. So for MATLAB, everything is a vector. Okay. So when you are calculating numbers, and that number is a matrix or a vector, then every time a new element is calculated, MATLAB will add that element to the previous vector. For you can see an example over here. Okay. So t is a vector, right? T is a vector which goes from 0 to 50, and the increment is how much? 0.02. How many elements in this? Somebody can tell me? How many elements in T? $250. Huh? So 250 elements in T. Okay. So T is created, right? T is created with 250 elements. Then you come in the program. What the program is doing, it is calculating y, and y is cos of t. Y is cos of t. Okay. So y should also have 250 elements, right? But I am adding these 250 elements one by one. For t, I did it in one statement, right? One statement goes from 0 to 50 elements stored. But in case of y, every time the loop runs, the program has to increase the memory of y. With every loop, the size of y is increasing one by one. Okay, so it can take a lot more time than t. Assigning 250 values in t will take less time as compared to assigning a value each time into each time into y. Okay, so you can do pre-allocation of the memory. Okay, and for pre-allocation of the memory, you can so you can see another example here. In case of this example, we are calculating the value of y, and y can be either equal to 1 or 1 by t. Y can be 1 or 1 by t. Okay, so if t of I, meaning the ith element of t, if it is greater than 1, then y should be 1 upon t. If it is less than 1, then y should be 1. Okay, so in this example, every time the loop runs, each element will be added to y again one by one. With each loop, y will increase by a size of 1. Okay, so what can we do? What do we mean by pre-allocation? You can see on the top here. We still have the same loop, but we created y. Okay, so we already created a matrix or a vector y which has same size as t. Okay, so earlier in the earlier programs we were using size a1 and a2, right? Meaning what? A1 means what? Number of rows. Okay, and a2 means number of columns. If you don't specify 1 or 2, it means the whole size, complete size. 4 rows 4 columns means size is 16. Okay, 3 rows 2 columns means size is 3 to 6. Okay, so you can use the size function without mentioning rows or columns, then it will take the total size. Now tell me, y one's size of t, what will it generate? What will be the answer of this statement? When you do this, y equals to what? What is the value of y? All of them are ones. Okay, all of them are ones, and the size is equal to same as the t. Okay, so if t has, now they have changed, how many elements? 50 now. 50 elements. So y will have again 50 elements, and all of them will be 1. Now we don't want all the y's to be 1, right? It's just initiation to allocate the memory in MATLAB. So MATLAB already has a variable which has 50 elements before starting the loop. So now it will just change the elements. Okay, so this is supposed to make the working more efficient, working of the software more efficient. Okay, so pre-allocation is done to make the working of the software more efficient. Creating a new member every time the loop runs takes more time than changing a pre-existing value. So it already has 50 values of ones. Changing them will take less time as compared to creating each value every time. Got it? Okay, so you have it, then you run the loop, then you have the if condition. If this happens, then change the y to 1 upon t. If this doesn't happen, then keep the y equals to 1. Now again, another thing, if t is not greater than 1, then y should be 1, right? If t is not greater than 1, y should be 1. It's already 1. Okay, so you can see that program is now much more simpler as well. In the previous version, I have to give both of them. If t is more than 1, what should it do? If t is less than 1, what should it do? Okay, but because in the second condition I want y to be 1 and it's already 1 here, so if t is greater than 1, change y, otherwise don't do anything. Simple. Okay, so again, so the point is pre-allocation of memory according to the size of a variable can make the working of the program more efficient in terms of time and memory. Okay, so before we start generating the loop, we can allocate we can assign that variable, we can create that variable, and we can assign some random values, 1, 0s, whatever. Okay. Okay, another type of loop is a while loop. Again, something which we used earlier. While loop will do what? While loop runs how many times? We have for loop and we have while loop, right? Maybe it's in the exam today. So while loop does what? So for loop runs from 1 to whatever number of times, right? While loop runs how many times? What is the difference between for and while? Anyone? Seriously? Take a guess. Nobody knows. Okay. What? Same. They are same. Okay. Maybe the people at MathWorks should know about it, right? They don't know they are same. They call one as for, the other one as while. They don't know they are same. You should let them know. Zainab says they are same. You don't know. You are giving them different names. While loop runs according to a condition. So until and unless that condition is met, the loop will keep on running. When the condition is not met, the loop will end. So there is not number of times specified here. In for loop, we specify the number of times the loop has to run. From 1 to 3 or 1 to 5 or 1 to 50. In case of while loop, there is no number specified how many times the loop will run. We will specify a condition and the loop will keep on running if it is million times until the condition is there. Okay, so you specify a condition, as that condition or the variable in that condition is used or changed inside the loop. Okay, for example, you can have a while loop which will run till x is less than 5. So when the value of x becomes equal to 5 or more than 5, the loop will end. So if it becomes 5 in 50 loops, it will end in 50 loops. If it becomes 5 in 10 loops, it will end in 10 loops. Okay, so there is no number specified here. So for example, if I want to write a while loop which will display the numbers from 1 to 5. Okay, which will display the numbers from 1 to 5. So which is what they did. Okay, clear? You can see no display outside the loop. It is running from less than equal to 5. So when it becomes 5, it will still run. So in this case, the last value of x is how much? 6. Because till 5 it will run. It will end when x becomes 6. Okay. Now we want to have a loop which will do the summation of numbers from 1 to 5. Okay. So for summation we know we have to initiate. Okay. It's already initiated, but we will make it 0. Okay. Then we don't want to display okay, and we don't want this, we want Okay, I made one example in the previous program as well, and as well as in this one. You did not see it, but the variable. Okay, this one I can use. So then I will do I equals I plus 1, and then I, the first value is. Okay, you can mark I equals to 0 in this case. Okay, clear? So the mistake which I made was the variable of the loop should not be the variable which you are calculating. Okay, the variable of the loop is what? I. So I will change from 1 to 5, right? Okay, and I'm calculating summation in x. So I cannot use x in both cases. You cannot say while x less than equal to 5 and then x is a summation. Okay, so I is the number which is going from 1 to 5 and the summation is what? X. Okay, so here they are, instead of x they are using sum. Okay, but the variable and the summation should be two different variables. The loop variable I or j or whatever, and the variable in which you are calculating the summation or doing anything should be different. Okay, that's why you would see in all the programs for loop they normally use I or j, and then they don't touch it, they don't make it anything else. Okay, but I keep on messing it up. So okay, write a script which finds the position of the first 0 in a vector named a. Okay, so first of all we will insert the value of a, which you can see over here. So they are doing it the other way around. Okay, so the loop will keep on running until while is not equal to 0. Sorry, you give the condition for the loop to run. Okay, so the loop should run when I is not 0, right? The loop should run when I is not 0. If it is 0, the loop should run or end. Okay, so not 0. Clear? That was my mistake. Sorry for that. Okay. Now, a very interesting problem. We did something like this in VBA as well. Sometimes we have a function, okay, and this is called function approximation. So we try to find out the approximate value of function when the error is minimized. Okay, a function has many terms, so the loop should keep on running until the error is minimized. Okay, so they call it convergence basically. To minimize the error, we call it convergence. Okay, so here you see here, we will keep on running the loop for this equation until the difference between the value of the equation for two x values is less than 0.0001. Okay, so what does it mean? When you put x equal to 0 and then you put x equals to 1 and you calculate the value of the equation in both cases, for putting x equals to 0 and putting x equal to 1, then you calculate the difference between them. If the difference between them is less than 0.00001, then the loop should end, otherwise it should keep on running. You get my point or not? So in this equation, first of all put x equals to how much? 0. Calculate the value. Let's say the value is 3. Let's say. Then you put the value of x equals to 1. You calculate the equation again. Now let's say the value is 5. Okay. How much is the difference between them? 2, right? Is it less than my required value? No. So the loop will try another value of x. So now it will try 2. Okay. then it will calculate the difference between what? 5 and the next value. Got it now? Okay, everybody clear? Okay, so the loop should run until the difference is this or more, right? If it is less than this, then loop should end. If it is less than this, loop should end. So the loop should keep on running until the difference is more or equal to 0.0001. Clear? Okay. Now they have already given me, when you put x equal to 0 here, the function or the equation gives you how much? 0. So I know the first value is 0. I'll show you the program, okay? So pay attention. Okay, so the first value of x is what? 0. First value of x is 0. And we also randomly put a new or the old value of x as well, which is how much? 10. So we have generated two values of x, the new one and the old one, to start the loop. So when you take the difference between the new one and the old one, how much is it now? 10 minus 0, right? 10 minus 0. And how much was my error value? So when you do new minus old, for the first time it will be how much? 10. So loop will run. Okay. So loop will run when you are greater than 0.001. So the first value is 10. So it will run. And then I want to also calculate in how many times I reach this solution. So I also initiated the iteration variable. Okay. Inside what I'm doing, the new value becomes the old value, and the program will calculate another new value. Got it? Okay. This was the new value of x. I stored it in the old value, and the new value I will calculate it using the full equation. Okay. So we already have the equation. They have used the equation here. You can see the exponential function and so on, and the iteration will change by 1. So it will go to the while loop again. It will calculate the difference between the old and the new value. If the difference is more than 0.001, it will run again. Got it? So again, the new value will become the old one, and the new value will be recalculated, and the iteration will be increased, and so on and so forth. So after the program finishes, it will give me the final value of x, and it will give me in how many times I reached the value of x, the approximate value of x. Clear? Any questions? Okay, so let's say we have formed a tank using a cylinder and a cone. Okay, you can see the cylinder, you can see the cone. We joined them together to make one tank, one water tank. Okay, you may have seen them in the chemistry exams or chemistry labs. Okay, they have something like this, a cylinder on the top, and then they have a funnel at the end. Okay, so it's like this. Volume of the cone, this is the equation, 1 by 3 r pi r square h. What is r? Radius. And what is h? Height. Okay. Volume of cylinder, pi r square h. R is again the radius, and h is the height of the cylinder. So here it is the height of cone, and here it is the height of cylinder. Now I want to fill 3 cubic meters of water in this. Okay, I want to fill 3 cubic meters of water. Okay, so the radius or the diameter is fixed, right? I have to see to how much height I should fill the water, right? If I fill it up to this much, it is less. If I fill it up to this much, it is more. So the program should calculate the height up to which the water should be filled, so that the total volume is how much? 3 cubic meters. Okay, again, since we don't have the time, I just directly go to the program. So height initiated 0. 0 height means No water. No water, right? R, the diameter is given as 1.2. Diameter of the cone and the cylinder, they are same because they are on one upon each other, right? They cannot be different. So the diameter of the cylinder and the cone is 1.2 meters. So radius is half of diameter, right? Height of the cone 0.6 meters given. Okay. Okay, height of cone is this much. And total volume for now 0, right? When height is 0, volume is 0 because you are multiplying, right? Okay, no water, no volume. Then you calculate the while loop. How much water I need inside? Volume to be 3. So the loop will keep on running until the volume is less than 3. Now what you are doing inside the loop? You will change the height by 0.001. So each time the loop will increase the height by 0.001 and check again. Clear? So increase the height by 0.001. If this height is less than the height of the cone, then the water is only inside the cone, right? It is not in the cylinder. So the volume of water is the volume of cone. Got it? Clear? Let me make it here. So if the height of water is less than the height of the cone, where is the water? In the cone, right? Okay. So the volume is volume of cone. If the height of water is more than the height of the cone, then the water is up to here, right? The total volume is this plus this. Okay. So this is what they are checking here. So if height of water is less than or equal to cone, the volume is the volume of the cone. If it is more than the volume, the height of the cone, then the total volume is volume of cylinder and volume of cone. Got it? And then it will end the if statement, end the loop, and it will go back and check, did you achieve 3? No? Run it again. Okay, so next time it will again increase the height by 0.001 and do everything. Okay? When you reach 3, the program will end. It will show you at what height the loop ended. Clear? Any questions? Sure. Done. We are done. Okay.